Hello and welcome to our lesson on applied geometry. In this lesson, we'll build on our ability to measure angles and learn to specify direction using a compass and bearings. We will first understand how a compass is used to determine direction. Then we will learn about bearings and how they are used to describe direction precisely. We will then practice applying this knowledge to various scenarios where specifying direction is crucial, such as navigation and map reading. In our previous lessons, we've laid a strong foundation by learning to measure angles effectively. We have learned how to use a protractor to measure angles. And we have also discussed units of measurement for angles, specifically degrees. With this solid understanding of angle measurement, we can now introduce the concept of bearings and compasses. Magnetic compasses have been used for thousands of years, and both compasses and bearings continue to be used widely today in areas such as navigation, surveying, and some sports. For example, if you were navigating a ship or an airplane, you would use a compass and bearings to describe and follow the precise direction of travel. By learning about compass usage and bearings, you will gain a crucial tool for specifying direction, which is indispensable in many real-world applications. Let's dive in and explore how to master this technique. A compass has a needle that always points towards the Earth's magnetic North Pole. The compass base is typically marked with the four main cardinal directions: north, east, south, and west. Additionally, between these main directions, we have the intercardinal points: northeast, southeast, southwest, and northwest. Bearings are a way of describing direction more precisely than just using cardinal or intercardinal points. A bearing is always measured clockwise from the north direction. Bearings are expressed as three-digit numbers. So, north is 000 degrees, east is 090 degrees, south is 180 degrees, west is 270 degrees. To measure bearings, you use a protractor. Suppose we have the bearing shown on the right here and we want to measure it. Start by placing the protractor's midpoint at the starting point of the bearing. Second, align the protractor's zero line with the north direction. Finally, measure your required angle clockwise to get your bearing. So in this example, the bearing is 40 degrees, which we write as 040 degrees. Let's now consider some examples to develop our understanding of this new technique. Suppose a car travels 10 miles at a bearing of 40 degrees and then 5 miles at a bearing of 180 degrees. We need to determine the car's final location. First, draw the initial direction of north. Place your protractor's midpoint at the starting point on your paper. Measure 40 degrees from due north and draw a line to represent 10 miles. This might be 10 centimeters if you use a 1-to-1 scale. Mark the end point of this line. This is your new starting point. From the new starting point, place the protractor again and measure 180 degrees, which is directly south. Draw a second line of 5 miles, using the same scale factor as the previous line of 10 which was drawn. Then connect the starting point to the final endpoint using a straight line. Measure the length of this line to determine the distance with your chosen scale factor. We find that this length is about 7 centimeters, which is 7 miles in real life. Then, use your protractor to measure the angle from the starting point's north to this line. This gives you the bearing from the original point, which is about 068 degrees. Let's move on to another example. Suppose you need to navigate a boat from point A to point B, and then from point B to point C. To find the bearing from A to B, we set our protractor to be aligned with the north line at A. We then measure the bearing. In this case, it's 100 degrees. Next, to find the bearing from B to C, place your protractor at point B and measure the angle clockwise from north to the line connecting B to C. As seen below, this turns out to be 35 degrees. By following these bearings, you can navigate accurately from one location to another. These examples illustrate how to use a compass and bearings to specify direction. By understanding and practicing these techniques, you'll be well prepared to apply them in various real-world contexts, from navigation to map reading. In today's lesson, we explored the use of a compass and bearings to specify direction, an essential skill in geometry and real-world navigation. We started by understanding the components of a compass, focusing on the needle that points towards the magnetic north and the cardinal directions, north, east, south, and west, along with the intercardinal points. We then introduced the concept of bearings, which describe direction more precisely using 3-digit angles measured clockwise from north. For example, north is 0 degrees, east is 90 degrees, south is 180 degrees, and west is 270 degrees. We also practiced measuring bearings with a protractor, ensuring the protractor's midpoint is at the starting point and its zero line is aligned with the north direction. This lesson emphasized the practical applications of compass usage and bearings in fields like navigation, geography, and sports. By mastering these techniques, you gain valuable skills for accurately describing and following directions, enhancing your understanding of measurement and geometry in real-world scenarios.